We are now going to discuss a new type of molecule, the alkene. To name an alkene, we're going to follow the same basic steps that we followed for naming alkanes and haloalkanes. First, you want to identify the parent chain, which is the longest chain. In this example, we have 1, 2, 3, 4, 5 carbons, so this is going to be pent. Next, we're going to list the substituents. We have one substituent. It's this 3-fluoro group. Next, we're going to number the parent chain so that the site of the double bond gets the lowest number. So in this case, our carbon 1 is where the alkene begins, where the first double bond is. So that will always be numbered 1. So if you remember, this molecule is somewhat symmetric. If we numbered this way, we would also get a 3-fluoro group, but in this case the first bond would be 4 for the alkene. So we're going to number it left to right. So I'm going to cross these out. So in this case, this is pentene, but it is 1 pentene. It's 1 because the alkene begins at the 1 position. And then we're going to put the name together alphabetically. So in this case, this is 3-fluoro 1 pentene. Another way of describing this sometimes is 3-fluoro pent 1-ene. That way we're saying the alkene begins at carbon 1. Let's take another example, this longer chain here. We can number this. First, identify the longest chain. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Alternatively, we can number from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, we can either start with a 4 or a 5 for our alkene. We're going to choose the numbering that gives the alkene the lowest number, which is 4. So let's go back through and redraw the numbering so it's not confusing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be a non-ene. It would be 4 non-ene as our parent. The next thing that we need to include is the substituents. We have an 8-methyl group and a 6-chloro group. So 8-methyl and a 6-chloro. We're going to list these alphabetically, so we're going to put chloro first. So this is 6-chloro, 8-methyl, 4 non-ene, and the last thing we need to do is include the stereochemistry found at the 6 site, which is for our chlorine. So let's go ahead and do that really quick. This is 1. If we're trying to differentiate what is the higher substituent, the next carbon over here or here, an alkene counts as a branch. So it's basically 2 bonds to a carbon. So this site here has 1 bond, this site here has 2 bonds. So this will be the higher priority. So this is 2, 3, which is counterclockwise, which would be S, but because the chlorine is back, this will be R. So this is R, 6-chloro, 8-methyl, 4 non-ene. The last thing that we need to talk about is how to characterize different alkenes. We have different degrees of substitution depending on how many alkyl groups are attached to a double bond. If you want to do this quickly, we can just look at how many new bonds there are. Right here, there's 1 bond. You can also draw the hydrogens in, and anything that is not a hydrogen will count as a degree of substitution. So this example has 1 degree of substitution. We would call this alkene mono-substituted. Another example here, we could draw in the hydrogens, but we have 2 bonds attached to the alkene. This will be disubstituted. Another example here, we have 3 bonds attached to the alkene. This will be trisubstituted. And in the final example here, we have 4 bonds attached to the alkene. This will be tetrasubstituted.